Today topic data link control. The Karpagam College of Engineering, presented by Dr. T. Ravichandran, Professor and Head, Department of Computer Science Engineering, Karpagam College of Engineering. Today we are discuss about the data link control. Data link control protocols for the data link layer. The data link layer divided the two parts. One is the logical link control, another one is the medium access control. The data link control, the data link layer, the functions of framing, addressing, synchronizing, flow control, error control, access control. The 6 responsibilities mainly concentrate for the data link layer. The data link control protocol, the first responsibility for framing. The data link layer need to pick the bits into frame. The collection of bits to arrange as a frame. The lower layer of the physical layer to prepare the zeros and ones to bits. The bits collection of bits to arrange it for the frame, so that each frame is distinguishable for another. The flags are assigned for the flag and header and tail and variable size of the data for arranging the frame structure. The frame structure forming the bit stuffing and unstuffing control. The continuously 5 ones are comes under the data missing structure. They are arranged for the stuffing for the zeros, and lower layer to upper layer flow from that the structure to receiver side automatically remove the zeros and connected for the data. Flow control and error control structure mainly concentrate for the data link layer control protocols. The data link layer protocols are divided into two categories based on the whether transmission channel is noisy channel and noiseless channel. The protocols divided the noiseless channel and noisy channel. Noiseless channel has a two structure. One is the simplest and another one is stop and wait protocol. Noisy channels, the three categories. One is the stop and wait protocol, another one is go back and ARQ, and selective repeat ARQ. The data link layer protocols mainly divided the two part. One is the noiseless channel and another one is the noisy channel. Noiseless channel performing for the two categories, one for simplest channel, another one is stop and wait protocol channels. And noisy channels categories for the mainly three categories. One is the stop and wait ARQ protocol, go back and ARQ protocol, and selective repeat ARQ protocols. First, noiseless channel. Identically channel, no frame loss, corruption and duplications available in the channel. Directly the data are transferred from the sender to receiver. All the data are correctly sent from the sender to receiver. No noise are occur from the channel. So that the two main categories of the noiseless channel is one is the simplest protocol and stop and wait protocol. First one is simplest protocol. Directly the data are sent to the sender to receiver. The receiver to collect all the sending frame to sender and receive to the sender to receiver. The same way, the second one is stop and wait protocol. The sender send the frame, wait for the response for the receiver. The sender send the frame, the particular time the sender waiting for the acknowledgement for the receiver. When the acknowledgement will arrive, the receiver side, then they send the next frame automatically. The sender send the frame, wait for the acknowledgement. The acknowledgement is received from the sender ready to transfer the next frame. So the sender wait particular time period and then they receive the acknowledgement after transmit the second frame. That method is called a stop and wait protocol. The stop and wait protocol. Our diagrams for the sender A, receiver B. The request frame is sent to the A to B. The frame is arrived and then receiver give the acknowledgement. The acknowledgement arrived from the sender A. The sender A generated the second frame to the receiver. That technology, that architecture, the form as the stop and wait protocol. Next one, the data link layer. The mainly the dominative protocols for noisy channel. Stop and wait, automatic, repeat request. Stop and wait, AIRQ, and sliding window, AIRQ. Go back in, AIRQ, and selective repeat, AIRQ. The stop and wait AIRQ, the stop and wait automatic repeat request. The characteristics used for connection oriented communication. It is offer the error and flow control. It is used to data link and transport layer. Stop and wait for AIRQ mainly implemented at the sliding window protocol concept with the window size of 1. The propagation delay, amount of time taken from the packets make the physical journey from one router to another router. The propagation delay is equal to distance between the router divided by velocity of the propagation. The round trip time, RTT, the amount of time taken by the packeters to reach the receiver plus time taken by the acknowledgement to reach the center. The time out of T2 is equal to 2 into T RTT. The time to live TTL is equal to 2 into time out. The maximum of TTL is 255 seconds. The operation for the stop and wait AIRQ protocol, the three problems are solved by the stop and wait AIRQ protocol. It is thus the both connections for when the case 1, when no problem for the sender to receiver, the sender sent the frame to receiver, the receiver into the acknowledgement at the particular time period. Automatically the sender accept the acknowledgement to generate the next frame. Then case 2, when the acknowledgement is lost, the sender send the frame, the receiver receive the frame, then receiver generate the acknowledgement. Acknowledgement lost the particular time period, wait for the sender, the acknowledgement is not received. So sender automatically retransmit the same frame. This is the first case. The second problem for that, the frame has lost. The sender send the frame is not reached the receiver. So the receiver cannot be given the acknowledgement. The particular time period, wait for the sender, the acknowledgement is not reached. Particular timeout is over. Automatically the sender decided to regenerate the another frame. Then third case of that, the case 4, when the acknowledgement is delayed, the sender send the frame to sender to receiver, the frame to reach as a particular time, the receiver generate the acknowledgement to reach at the center, the timeout is over. The particular timeout cannot be reached at the time. So automatically the sender known as the acknowledgement is lost or frame loss, that condition is occur, automatically the generated for the next frame. So the mainly three problems is there in the stop and wait protocol to use in the automatic repeat request. One is the acknowledgement loss, another one is the frame loss, and third one is the acknowledgement received as the delay. The advantage of stop and wait protocol, the simply implementation, the error detection and flow control and backward capabilities. Disadvantage for the ARQ, the low efficiency, high latency, the limited bandwidth utilization, the limited error recovery. Mainly concentrate for the second noisy channel ARQ protocol, the sliding window protocol. The sliding window protocol categories for the two type. One is the go-back-N ARQ and another one is the selective repeat ARQ. The sliding window protocol, both side receivers or senders are agreed on the number of data frames after which the acknowledgement signal should be sent. So the sender and receiver can be interchanged the multiple frame without acknowledgement. If receive the frames on the sequence in order, the sliding window follow the rules for pipelining. The first protocol for go-back-N, the selective window protocol, first protocol for go-back-N. Both sender and receiver have finite size of the buffer is called as the window size. The number of frames to be sent depends on the window size of the sender. When the sender buffer is full, when it's waiting for the acknowledgement, which will be received, the receiving of the buffer is full. When the if acknowledgement is frame is not received with the agreement period at the time period, all the frames in currently windows are transmitted. This is the go-back-N, N number of window size to be on transmitter. This is a go-back-N. The sender and receiver calculated to decide the how many size of the buffer to be allocated for sender and receiver. Our example, the 4 number n as take the 4. So the size of that the window assigned for the frame as 1 to 10 and buffering of the transmitting and receiving size of the window is 4. So first 4 number of values to be sent to the sender to receiver 0, 1, 2, 3. The 4 frames are sender to receiver. Then the sender waiting for the 0th from acknowledgement. 0th from acknowledgement is received. Automatically 4th frame is centered. Automatically the window size is sliding to the 0 to 1. Then waited for the next case. The window size, the receiver is sent to the second acknowledgement. The first frame acknowledgement sent to the sender. The sender waiting for the particular time to receive the first frame acknowledgement. Automatically the sender decided the first frame is safely reached the receiver. So the windows, sliding windows is adjusted to 0 to 1. Next size is 2, 3, 4, 5. So next the sender is waiting for the next acknowledgement. The second frame acknowledgement is lost. Second frame acknowledgement is lost. So sender is particular time to be on waited. The sender cannot be on received from the second frame acknowledgement. So automatically the sender is main to the that is the all the frame sizes are discarded. So the 2, 3, 4, 5, the 4 size of the buffer data are retransmitted. The n size of the buffering data are recentered. The 2, 3, 4, 5, the 4 frames are sending to the sender to receiver. This is the main concept of the Cope-back and sliding window protocol. Another one is the very effective and most of that application can use it for the selective repeat ARQ. The same condition is there. The frame size is set from the sender to receiver. Now we are selective repeat ARQ you can use it for the window size is 4. The same condition the selection is 4 size. The sender to send the 0, 1, 2, 3 the 4 frames are sent to the sender to receiver. The receiver accepted to send the acknowledgement to sender. The first 0th frame is received. The 0th frame acknowledgement reached to the sender. The sender decided the 0th frame is safely reached. So automatically the sender generated to the 4th frame. Next one first frame is reached at the receiver. The receiver automatically give the acknowledgement for first frame. The sender is received from the first frame acknowledgement. The sender is sent to the next frame of 5th frame to be sent to the sender to receiver. Next one, the second frame acknowledgement is not reached. Second frame acknowledgement is not reached. The sender wait for the particular time. So the sender select the particular frame. Which frame acknowledgement is not reached. So the automatically sender select the particular frame of the frame number 2. The frame number 2 to the retransmitter. Frame number 2 the retransmitter. The comparison between the Cope-back N is the full buffer frames are retransmitted. The selective repeat ARQ is only for the select the particular frame of the frame number 2 only to be on the selector to send to the sender to receiver. The major difference from the selective repeat ARQ and Cope-back and ARQ. This is the today we are discuss about the data link control protocol. This is the mainly concentrate for the data link layer. The data link layer responsible for the 6 responsible. The mainly concentrate for the framing. The framing structure we are continuously the ones are occur from the data. The stubbing values are inserted. The receiver side remove the stubbing of the zeros and collect the original data. The same structure we are used for the main protocols are accepted. The data link layer having the two structure of the protocols. One is the noisy channel and another one is the noiseless channel. The noiseless channel having two types. One is the simplest and stop and wait protocol, and noisy channel having the three main concentrate for the main three categories. One is the stop and wait protocol ARQ and Cope-back and ARQ and selective repeat ARQ. The main concentrate for the 5 type of the protocol structure can use to transmit the sender to receiver. Thank you for all. Thank you very much.